So we're going to talk about similarity, and in specifically figures that are similar to each other. And it's pretty common for people to say that similar figures have the same shape, but not the same size. And those are similar figures. And okay, while that's a good way to think about it, I think that it's better to come up with something a little more strong than just same shape, different size. So here's what I'm going to do. I'm going to take this triangle, I'm going to make a copy of it, we'll clone it, and I'm going to make that one a lot bigger. So notice that what I've done with this triangle, if I can grab onto it, hey, grab that triangle, there we go. I'm noticing that the top angles are the same size, and that the bottom angles on the right are the same size, and that the bottom angles down there are the same size. So the angles to them are going to be congruent angles. So if we mark them like this, and again, I don't know if that angle that I just marked there is a right angle, but it's okay. And if I make up some side measurements, let's call that side like 3, let's call that side 5, and let's call that side 6. Just going to make up some numbers. Because I cloned and enlarged it, there's a scaling that goes on here. So maybe we'll say that this side is 6, this side would be 10, this side would be 12, because all the sides would increase at the same rate. And I think that's it motivates a lot better definition of what similarity really is. So the way we're going to complete this is that two figures are similar if and only, if we'll talk about that if and only a phrase for a second, if the corresponding sides are what we call proportional, and their corresponding angles are congruent. That's what it means for two figures to be similar. So if you know that two figures are similar, what it means is that the corresponding sides make a proportion, that they're in the same ratio to each other. And you also know that the angles are congruent. And likewise, if you're trying to prove that two figures are similar, if you have two figures whose sides are proportional and angles are congruent, then it is similar. That's the if and only if part. It goes both ways. So, for example, if you like corn and peas, we're going to use this symbol up here for the similarity symbol. So it kind of looks like the congruent symbol. Do you remember the congruent symbol had the equal sign and then the squiggle on it? Well, this is just the squiggle on it. That means similar. So if figure corn is similar to figure peas, that means that, as you see on the left, the corresponding angles are congruent. Angle C corresponds with angle P. So those angles are congruent. And the same with angles O and E, they're congruent. R and A are congruent. They're the ones that are marked in kind of purplish and green. And angle N and angle S are congruent. And it also means that the corresponding segments, the sides of the figure, are proportional, meaning that the ratio of side CO to side PE is going to be equal to the ratio of side OR to side EA. Notice that CO corresponds with PE the same way that side OR corresponds with side EA. And the other ratios are the same as well. So corresponding angles are congruent, corresponding segments are proportional. Let's play the similar figure game. I have two quadrilaterals here, quadrilateral small and quadrilateral biggie. That's not biggie smalls, come on. So we're asked to find the values of x and y. So in the figure on the, you know what, pause the video, figure it out. Hey, welcome back. So let's take a look. The figure on the left has angles of 78 and 83 degrees for angle S and angle M. So the corresponding angles, S corresponds with B, M corresponds with I, and so on. So angle B is a 78-degree angle, and angle Y, the angle or who's with the variable Y, is 83. So Y is equal to 83 because if the figures are similar, which they are, corresponding angles are congruent. And the corresponding sides are proportional. So what that means is I can write up an equation. I can write a proportion, two equal fractions. So I'm going to use the fact that side SL corresponds with side BE. And I'll make a proportion like 18 is to 24. And that is going to be equal to a ratio of the other two sides. This side here, 21, to this side here, x, 21 over x. So we can solve this equation a number of different ways. One thing that I notice is that 18 over 24 can be reduced to 3 over 4. That might make my multiplication a little bit easier. So if I reduce this to 3/4, now it's not too bad. If I do 4 times 21, that's 84. 3 times x is 3x. If I divide both sides by 3, 3 goes into 84 28 times. So x is equal to 28. So please notice we did that by multiplication. We didn't do that by addition. I've seen a lot of students go, well, 18 plus 6 equals 24. So 21 plus 6 is that side. Boy, that's bad. Don't do that. They're related by multiplication. It's a proportion. So hopefully that helped you with understanding similarity.